Madland, and this is my project, Sea Monkey Survival.
Question or problem?
This project concerns the hatch rate of brine shrimp when exposed to different levels of microplastics. In 6th grade, I worked with microplastics expert Mark Ward to determine where the plastics came from along the Oregon coast. In our conversations, Mr. Ward warned me of the toxicity of these plastics and encouraged me to wear things like gloves while handling them. This got me interested in how toxic these plastics actually were to smaller animals like zooplankton, such as brine shrimp. In my project, I added increasing amounts of marine microplastics to 11 petri dishes to see if it affected the hatch rate of these little animals. I found that the presence of microplastics drastically changed the hatch rate, but I still need to fine-tune my project to get greater results.
Hypothesis or solution?
I think that increasing amounts of plastic in the water will negatively affect the hatch rate of these shrimp due to the toxicity of the plastics.
Experiment or criteria?
In my first round of the experiment, I had 11 petri dishes filled with 50 milliliters of water each, a fixed volume of solids, and a tiny scoop of brine shrimp eggs that represented, on average, 130 eggs. I made a control petri dish where the solids were 100% aquarium sand. I then put an increasing amount of plastic, adding 10% more microplastics and 10% less sand in 10 individual petri dishes, so that the overall volume of solid remains the same, with the last container being 100% microplastics. After the eggs hatched and I had given them 3 days to develop, I counted all the brine shrimp in the 2 controls and the 10 petri dishes with increasing amounts of plastic. The variable was the percentage of microplastics in the solids. To control for errors, I made 2 control samples, one with 100% aquarium sand and one with no sand at all, just water. I was very careful to make sure the amount of water, the total volume of solids, and the amount of brine shrimp eggs was constant.
Results.
In my first experiment, I saw that the 2 controls, the one with the sand and the one without the sand, had a basically identical hatch rate. This meant the sand had no effect on the hatch rate, but the microplastics turned out to be way more toxic than I could have ever imagined. Basically, none of the eggs hatched, even in the ones with a small amount of microplastics. So I realized I needed to change my experimental design.
Conclusions/changes.
For my second round of the experiment, I decided to keep the water level at 50 milliliters, the number of eggs the same at approximately 130, and eliminate the sand from the solids because it had no effect on the hatch rate and made the shrimp harder to count. Instead, I made a control petri dish with no microplastics in it and added plastics with a very small spoon, approximately 1/10 of a cubic centimeter of volume. I added 1 more scoop to the petri dishes until I had 10 in the last one, which is approximately 1 cubic centimeter. The results of this experiment were not as clear-cut. While it did show a trend that the microplastics negatively affected the hatch rate of the brine shrimp, a winter ice storm cut power to my house, dropping the temperature to about 50 to 60 degrees Fahrenheit compared to the optimal hatching temperature of 70 to 80 degrees Fahrenheit. Since the temperature now became a second variable, I need to redo the experiment at the optimal hatch temperature, and I believe I will increase the amount of microplastics because I feel the amount was too low this time around.
Next steps.
In the future, as I mentioned earlier, I need to fine-tune the amount of microplastics I add to my petri dishes. I would also love to reach out to my contact at OSU to see if they can help identify the exact types of plastics I found to figure out which ones were the most harmful.
Impact.
The toxicity of these plastics is important to know about because plankton are the base of the entire ocean ecosystem, so anything that affects them negatively affects the entire ocean and the entire world negatively.
Inspiration.
My inspiration for this project was my love of ocean life and my concern for the pollution of beaches on the Oregon coast. This led me to my 6th grade experiment on where the plastics came from on our coast and where they concentrated. This got me curious about how toxic they were and what effect it was having on microscopic life at the bottom of the ocean's food chain. I thought of using brine shrimp, also known as sea monkeys, because they're easy to get and they're tough little critters. I was also excited to contact Anna Baum at OSU, who is doing similar work to mine. I hope to keep that contact because she is interested in the results of the science fair project.